Compute the limit. Let's say you're given this limit as it approaches infinity for this rational expression. To solve this rational expression, the first thing you need to recognize is that the leading term, which means the highest degree, for the numerator is the same as the denominator. Once you recognize this same degree for the numerator and the denominator, it involves factoring. So to solve this limit as it approaches infinity, for the degree that's the same for the numerator and denominator, you need to do the factoring method. You need to factor out the numerator's the highest degree and the denominator's highest degree. So for the numerator, the highest degree is x squared times, put a parenthesis right here. This involves a distributing method. So you put a 1 right here because x squared times 1 will be x squared as the given, plus 2x divided by x squared. How do you get this expression right here? You get it by, you take every expression, every term right here divided by x squared. As for the 3, also divided by x squared. Why do you divide it by the x squared? Because x squared will cancel out with this x squared, and you're left with 2x, which is the same thing as the given. That's the purpose of dividing it by the x squared, the term that you factor out. The 3 divided by x squared. Why do you put the x squared? Because x squared can cancel with the factor term of x squared. Once you cancel this one with this one, you're left with the 3, which is the same thing as the given. So that's the reason why you divide it by the term for 2x and 3. As for the denominator, you factor out the highest degree, which is 3x squared. Put a parenthesis times 1. Why is it times 1? Because 3x squared times 1 will be the same thing as the given, which is 3x squared. Minus stays the same as the given, and 6x and 9 you divide by the leading term, which is 3x squared. Why do you divide by 3x squared? Because 3x squared will cancel with the leading term, and you're left with the 6x, which is the same thing as the given. That's the purpose of dividing it by the leading term. The same thing for this one. 3x squared will cancel with the leading term of 3x squared, and you're left with the 9, which is the same thing as the given rational expression. Once you have all this, it's time to cancel the leading term. So this one, the denominator's x squared will cancel. The numerator's x squared will cancel with the denominator's x squared, because x squared divided by x squared is 1. So you're left with, on the numerator, will be like this, and on the denominator will be like this. Once you have this rational expression, it's time to take the limit as it approaches infinity for 2x divided by x squared. But before you do that, you need to do another algebra step for this expression and this expression and this expression and this expression. So 2x divided by x squared, on the numerator will be 2, and then on the denominator will be x. Why is it x? Because x to the first power, which is 1, and the denominator is the second power. So you minus 2. So it's the same, the answer will be negative x raised to the negative 2 exponent. To get rid of the negative 2 exponent, you put it on the denominator. I mean, this one will be -1 because 1 minus 2 will be -1. To get rid of the -1, you put the x on the denominator to make it positive. Because every time you have a negative exponent, you need to make it positive and you put it on the denominator. As for this one, it will stay the same because there's nothing to subtract. So on the denominator, 6 divided by 3 equals to 2. And x1 minus x2, minus x2 from the denominator will be x raised to -1. To make it positive, you put it on the denominator. And 9 divided by 3 equals to 3 divided by x squared. Once you do all the tedious algebra, now you could take the limit as it approaches infinity. So to take the limit as it approaches infinity for 1, it will become 1 because 1 is a constant. Every time you take a limit as it approaches infinity for any constant, the answer will be that particular constant. The second thing is to take this limit. Take the limit as 2 divided by x as it approaches infinity. So on a calculator, if you put 2 divided by a very large number almost to infinity, it will reach 0. The same thing for this one. And on the denominator, it will be the same too, because 2 divided by a very large number almost infinity, it will reach 0. And it's the same concept for this one. So you are left with the limit as it approaches 1 divided by 3. As I stated earlier, every time you take a limit as it approaches infinity for a constant, the answer will be that particular constant. So for this particular limit, the answer will be 1 divided by 3.